training, and talent development solutions. We are very excited to host today's webinar, AWS Machine Learning Masterclass, and presenting today's topic is Vishal Nigam. Vishal is an experienced AL, ML, DevOps, and cloud infrastructure expert with over 10 years of experience in GCP, AWS, and Microsoft Azure with DevOps, including Kubernetes, Docker, big data, etc. Vishal is an experienced corporate trainer, having over 10 years of experience in various technologies. Vishal also has delivered more than 3,000 corporate training batches on different technologies. He has built various products on blockchain and has more than 5,000 participants globally. He is also a global speaker. Now, please bear in mind that this is just an overview of a very robust topic, but we do offer a collection of technical and business courses that can be tailored towards your specific requirements. So if you're interested in a further discussion about those, you can make an appointment with our learning consultants through our website at www.netcomlearning.com. I want to let you guys know that today's session is also being recorded, so you will get free access to the recording in the next 24 hours via email. NetCom Learning helps customers build an innovative learning organization by achieving a smarter workforce, adopting to change, and driving growth. And we do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. And we have 9 practice areas in which we specialize. They encompass people, process, and technology training. And today's presentation is from the data and AI practice area. NetCom Learning offers a comprehensive training portfolio for data and AI courses, and our upcoming classes include various training on deep learning on AWS, practical data science with Amazon SageMaker, the machine learning pipeline on AWS, and so many more. Private training to teams is also available, and the learning plans can also be customized to the specific needs of each audience. You can also access a variety of data and AI marketing assets, such as our free on-demand training and blogs, by clicking on the available webinar handout. These offerings can also be found with a simple search on our website at www.netcomlearning.com. In this event, we will get an overview of AWS Machine Learning, and the event will not only talk about strategies for achieving machine learning at scale, but also the best practices for MLOps. I'm not sure if there's an acronym for that, but MLOps. Now, I'm just going to give you a quick overview of the logistics before we get started today. To start with, you have the option to adjust the window size to your liking. You can simply hit you can simply hit the escape key and find the Zoom button on the top left corner of your GoToWebinar viewer. Everyone has been muted except for the presenters, but you can feel free to submit any questions you have for the presenters in the questions panel, and we will address them at the end of the session today. Also, to get the best out of today's webinar, we've included the slides, courses we've talked about, and our marketing assets in the handout section of your GoToWebinar viewer, and you can refer to those to get a better understanding of the topic. And now, without any further delay, I'm going to go ahead and pass the time over to Vishal to present our topic. Vishal, we are very excited to have you, and you should be able to share.
Absolutely. Thank you very much, Leela, and good morning, everyone, and welcome to this beautiful masterclass on AWS Machine Learning. My name is Vishal Nigam, and as Leela introduced me in such beautiful words, I will be instructor for this beautiful webinar that we have on AWS Machine Learning. Now, before we get started, that is me on the screen, so you know that's not a bot talking about. So I'll quickly introduce myself again. As I said, I've been in training for over a decade. I build a lot of products, and I am a champion instructor at AWS. Apart from that, I'm a full stack dev. I do a lot of AI machine learning stuff on a regular basis, and I've consulted hundreds of organizations in that capacity. So that is the brief about myself, and I will not be taking a lot more time in this case. Now, this webinar, as I have to bring it up to all of you, that AWS has a huge offering in terms of machine learning. Now, covering everything in this class is pretty much out of scope, but we will be trying to understand some of the basic offering that AWS has to do. And I will also, give you some of the demos. I mean, probably a one demo where how we can use a service called a Sage Maker to kind of get started. Now, before we really start this whole discussion, we're going to talk about number one. Come on, what's happening? Okay, sorry. Why there is this? This is weird. Hold on. Let me hide thing. Okay, we're good. So the first thing I'm talking about is machine learning, not AWS machine learning, but what is actually machine learning on AI in that case. And that's something I believe is a must to really get started. Now, when we look at machine learning, and this one I'm talking about how it really adds value to different businesses and how Amazon uses AI in its products. And I'm going to talk about some of the use cases where AI plays an important role, and then probably some of the services that you can use to develop an AI-ready application. Now, if I simply state, AI is intelligent behavior by machines. That means any device that can perceive its environment and take the actions accordingly has AI. Now, by using AI, a machine can mimic cognitive human functions like learning and problem solving. And a common example of using artificial intelligence is giving machines the ability to scan and even interpret their physical environment so they can handle moving around and even up and down the stairs. Now, to take machines to act and react like humans, we need to provide them with information from the real world. In order to mimic this human intelligence, AI relies on something called as knowledge engineering. Now, knowledge engineering is the key component of an AI research. Let me write on the screen where I'm going to put it. So we are talking about at this moment something called as the knowledge engineering. Now, that's the topic that's I'm going to talk a bit about it. Now, knowledge engineering, as I said, is the key component of AI research. Machines with AI are expected to solve problems like the human would. And to do that, machines need extensive knowledge of the real world. In other words, they need to understand things like the relationships between object and situation, probably the properties of an event, cause and effect, a lot more than that. And this data is then processed and fed to softwares that in turn analyze the data and kind of come up with decisions for a particular problem the way humans do that. And if I have to kind of draw this for you, I would put it this way, that let's say we have knowledge plus some kind of, software program that helps me to make the decisions. Now, that's something which is a point of discussion here. So in short, the goal is to transfer the human expertise to a software program which can take in the same data and come to the same conclusions as a human would do. And this process of feeding data to a software program and coming up with a human-like decision is also known as a modeling process. This is where this entire process where we take the data and kind of come to a decision, we call it as modeling process. Now, because this is a recording, so you all be getting this, whatever I'm writing here in that case. Now, when we look at the modeling process, the model, which is basically your software algorithm, is consistently refined until its decisions are, close to a human would come up with. Now, if the decisions for a particular problem is inconsistent with a human decision would be, then we go back to the model and debug it until we improve that. And as you might expect, this is an iterative process. It needs to happen again and again. And AI presents us with the new possibilities and promotes growth in business. All kinds of companies are using AI to innovate. I mean, companies are making significant investments to improve their products based on the user satisfaction, their feedbacks, the trends, and a lot more. And they're using AI to do it. I mean, if I give you some of the examples of how AI is being used today, think about detecting and deterring the security threats and fraud, or resolving user technology issues through some automated call centers or a chatbot, or we have these automating repeatable tasks like payrolls or data entry and audit, and anticipating user action and providing recommendations, probably monitoring social media comments, maybe tailoring the advertisement content after the search trends. So once you start learning about AI, you start to seeing terms like machine learning and deep learning. And machine learning, which is also called as ML, and deep learning, which is also called as DL, are really the subsets of the AI. So you can create an AI system with the help of machine learning and deep learning algorithms. For example, a software program to probably predict some user action and suggest a recommendation, or maybe a system that is going to understand the thoughts and sentences spoken by a human like Alexa. So if you talk about these fields and you look at this capacity, the important thing that kind of happens to exist for us is, it's the data. Now, machine learning is often deployed where explicit programming is too rigid or impractical. So you don't want to deploy machine learning at every place. So you have data, then you are processing the data, and then you are getting the predictions. So if you look at this as a model, you would be able to understand that machine learning is now going to be deployed where programming is going to be too tough to do that. There's so many variables there. So unlike a regular code, machine learning uses data to generate the statistical code that will output the right results based on the pattern recognized from your previous examples of input. So machine learning kind of starts with the data it already has about a situation. It processes the data using some algorithms to recognize the patterns of a behavior and outcomes. It then interprets those patterns to predict the future outcomes. And these predictions are used to make a decision about the next step for the machine learning to take there. And that decision produces results, which are eventually evaluated and added into the pool of the data. And the new data would influence the prediction and subsequent decision made going forward. This is how a machine learning learns over time. So you can say that machine learning can make predictions from a huge data sets, optimize utility functions, and extract these hidden patterns, and even structures from the data set by classifying the data, which enables a software program to learn and make those predictions in the future. And deep learning, which I talk about, deep learning kind of takes machine learning to one step further. So rather than telling the machine what features it needs to look for, deep learning enables the machine to define the feature it needs to look or for itself based on the data that's being provided. So if I look at a simple example, let me kind of draw something for you so you understand there. So if you see, we have, let's say, this is a rectangle. And this is a circle. And please don't go on my drawing, okay? I'm still trying. So in this example, a traditional machine learning requires you to tell the machine how do you differentiate between a rectangle and a circle. Now, deep learning, on the other hand, will show you different machine learning examples of rectangles. So it's going to analyze those examples and infer the common features that defines a rectangle. So at this point, it can identify on its own whether a picture is looking like a rectangle in the same way your brain processes the information using neurons. So deep learning processes information using similar but artificial processing structure known as artificial neural network. So you may have heard the term artificial neural network. This is the neural network. And it builds the structure from the data it analyzes and then infer these features about its subject matter based on the data. And then it weights those features according to certainty and commonality and organizes them into layers, into a layer of hierarchies and relationship with each other. So to look at this example again, if a deep learning machine looks at a reference data on what a rectangle is, it can infer that rectangles are built from the four sides at the right angles. Unlike machine learning, deep learning, a machine doesn't have to be told to look at for the number or angle or the side instead. It's going to recognize the sides as a common feature of the reference data on its own, and it can then look at a rectangle there with the sides and can determine that this four sides is probably a rectangle since it has four sides at the right angles, even though it's four side appears to be equal and not, or bits of color that's including data, but it can reflect that. So to help you understand the difference between AI and machine learning and deep learning, I'm going to give you a very high level example of how these three might be applied to a common task of, let's say, a facial recognition. Now, we all understand what is a facial recognition here, where you want to identify a face, right? And if I kind of draw something, I'm going to do this. Let's say this is my machine. Sorry about that. Let's say this is my machine there. And this machine is trying to figure out someone as feature here. Now, that's the data you're giving to the machine there. And, if I kind of put an arrow, so I'm going to tell you where the machine learning comes into play. So we are in the AI part. That's the bigger circle of the AI. And let's say I have, so these two humans could be anyone, right? So let's say make two more or three more humans. Again, don't go on my drawings, okay? So if you look at this as example, now in this example, an AI wouldn't necessarily know that it was looking at three people unless it has been taught what to look for in order to spot people. And this requires a lot of trial and the error on the part of developers creating the algorithm. And it doesn't really involve the machine having to learn anything about what humans look like, other than the developers tell it to look for. So it's like fixed that, hey, you have to look for ABC features there. Now, the machine may be provided with an ability to identify the head shapes or probably skin tones, but without an ability to learn, the machine could simply fail because of the wide range of diversity in what humans look like. For instance, it might not recognize a person because of a beard, let's say, which could generate a false negative. So with machine learning, however, you can give these machines a rough framework for what a person looks like and the ability to iteratively process and learn other human appearances through an experience. So here the machine learning can recognize the figure in the middle. You can see there. Let's say it's closest to the figure probably which is there on the upside. I mean, just for example. And once it's confirmed that, hey, these appearance is a person's face, it becomes more confident in its ability to recognize human based on the facial and their hair shape, but less confident in let's say a different color of hair, to probably, let's say, black hair and brown hair. Now with this information, it might be able to recognize person three probably as confidence in the facial shape, which is high enough to overcome its lack of knowledge in other areas like what is the hair shape or skin tone. But because the machine learning was not prepared to recognize the facial hair ahead of the time, it still doesn't have an ability to recognize one of the person who has an hair. Let's say if I give machine learning that this guy has a beard, I'm going to draw a beard here. So probably draw some eyes and lips, and let's get this guy some beard. Okay, wow, that's a nice implementation. So let's say this is beard. The machine learning is going to have hard time to figure out that what a beard is, because we haven't taught and we haven't given the data to machine learning that even someone with a beard is still a human. And that's why deep learning is such a popular choice for a facial recognition, because with deep learning, the machine is provided lots of facial reference data up front, and unlike a traditional machine learning or AI, it isn't always told exactly what features to look for. It uses its highly advanced data processing capabilities and a neural network to derive the important features it needs to look for data itself. So rather than the developers telling the machine ahead of the time how to recognize a specific, how to define things like facial hair, the machine simply looks for the common features that defines all of the humans in its data and look for those in things that it sees there. Or in other words, I would say that the machine defines the essential features of its subject rather than the developer. So that's what kind of distinguishes deep learning from the traditional machine learning. And now, because you understand what AI is, I'm going to talk a bit about how you can establish probably an AI strategy. I mean, it's important for you to establish an AI strategy, right? You can establish an AI strategy in your organization with the help of a fast computing environment, and you have data that's gathered from different sources like social media or browsing intents or a lot more, and advanced learning algorithms. So if you look at the data in the first place, which is a part of the slide, that more data means analytics or better analytics, and better analytics results in better products, and better products mean more users, and that in turn generates more data for you. This is, in simple terms, is like a flywheel of data. So you can gather data from a number of sources like a clickstream data and a user activity, and then you can analyze it to using tools like Hadoop and Spark and Amazon Elasticsearch surveys. And using the analysis, you can feed the AI and the machine learning algorithms to form pattern recognition and generate these predictions. And then you can use those predictions to make your product better and drive more users to do that. And by using a combination of programming models, algorithms, data, and hardware acceleration with infrastructure like GPUs, you can actually develop a framework that kind of helps with AI-enabled features like image understanding or speech recognition or natural language processing or autonomy. And these combination of programming models, algorithms, and data is, usually what forms the basis of machine learning and deep learning frameworks. And the underlying hardware structure or infrastructure supports those frameworks. Now, today, AI is being used across all Amazon. On Amazon.com, you see a recommendation that is suggested by Amazon's recommendation engine, which improves your shopping experience. So we kind of use AI to spot the trends in the customer experience so that we can develop new products and enhance those existing products. And in the fulfillment and logistics department, there are robots who pick and file and sort and move the boxes around so they can be shipped to the customer, and the employees used to have to walk miles each day. So by using AI, Amazon is saving time and freeing up our staff to serve more customers faster. So now AWS is making AI tools broadly available so that businesses can innovate and improve their products. So Amazon Web Service offers a range of services in AI by leveraging Amazon's internal experience with AI and the machine learning. And these services are separated according to, I would say, different layers of the modeling. So if I have to talk about, the services there, and I will actually use a blank screen, which is where I do this. So that's what we call as Amazon Machine Learning. Now, Amazon Machine Learning, as I said, it's going to give you that part, and we'll talk about some of the services there quickly. So if I'll tell you a model here, we use AI in AWS, all right? And if I'm talking about a service, there is a vision service. Then we have speech. We have chat. And there are a lot more that's going to come in there. So we have a service called as recognition, REKOG, recognition there. Then we have Poly as a service. We have Lex as a chat service. And then you have a lot of platforms. So you have the Amazon ML as a platform. We have the Spark and EMR as a platform. We have Kinesis as a platform. We have Batch as a platform. We have a lot more there. And then there are these engines that kind of makes it happen. So you have the MXNet as a platform. You have got the TensorFlow as a platform. You've got the Caffe and PyTorch. Again, a lot of these offerings that kind of happen there. And then there's infrastructure, on which you're running there. So you have GPUs, you have CPUs, you have IoT, you have mobile, and you can see we've got a lot of things that kind of happen there. So eventually, going to this segment there and going to this part of the model there. Now, these are services which are separated according to 4 layers. So AI service, platform, frameworks, infrastructure. And we can organize them from the least complex to the most complex, going from, let's say, top to bottom. So if I'm going to talk a brief about these layers, so the AI service are each built to handle a specific common AI task. And these services enable developers to add intelligence to their application through an API called to a pre-trained service, rather than developing and training their own deep learning models. So you have something there. So recognition makes it easy for you to add image analysis for your application. So with recognition, you can detect specific objects and scenes and faces like celebrities, and identify inappropriate content and images there. And you can also search and compare faces. So recognition APIs allows you to quickly add these sophisticated deep learning based visual search and image classification to your application. And then there's Poly, which is a service that turns the text into a lifelike speech, which allows you to, again, create applications that talk and build entirely new categories of speech enabled product. And Poly's text-to-speech services use advanced deep learning technologies to, to synthesize speech that sounds like a human voice. And Amazon Lex on the extreme red is a service for building conversational interfaces into any application using the voice and the text. And it gives you automatic speech recognition for, converting speech to text and natural language understanding to kind of recognize the intent of the text. And that lets you build application with a highly engaging user experience and a lifelike conversational interaction that there. So the AI platform layer of the stack review on products and these frameworks there. So AI platform layers of these trainings and machine learning model help you to kind of model your own data, and from there you'll be able to build a specific solution that can help you to kind of get a job done, which eventually is the important use case there. So for the customers who want a fully managed platform for building models using their own data, we have Amazon Machine Learning, which is again designed for developers and data scientists who wants to focus on building models, and the platform kind of removes these undifferentiated overhead associated with deploying and then managing infrastructure for training and hosting models. It can actually analyze your data and provide you with suggested transformation for the data, train your model, and even help you evaluating your model for accuracy. And there's this EMR, which is again a great feature. Now, EMR is a flexible, a customizable, and you can manage your big data processing platform. So it's a managed solution in that it can handle things like scaling and high availability for you. And EMR does not require a deep understanding of how to set up and administer these big data platforms. You get a pre-configured cluster ready to receive your analytics workload. It is built for, I would say, any data science workload, not just AI. And Apache Spark is, if you all heard about it, it's an open source distributed processing system commonly used for big data workloads. So Spark utilizes this in-memory caching and optimizes your executions for a fast performance, and supports a general batch processing. And then the streaming analytics and machine learning and graph database and ad hoc queries all can be run and managed on an EMR cluster. So and then there's the AI frameworks and infrastructure layer are for expert machine learning practitioners. So in other words, I would say that for the people who are comfortable, building deep learning models, train them and doing predictions, which is called as inference, and then get the data from the models into the production application. So the underlying infrastructure will consist of your EC2, P3 instances, which are then optimized for machine learning and deep learning. And then EC2, P3 instances provide you powerful NVIDIA GPUs to accelerate computation so that a customer can train their models in a fraction of the time required by the traditional CPUs. And after training, EC2 C5 compute optimize and aim for a general purpose instances. And in addition to these GPU-based instances, they are well suited for running inferences with training models. So AWS kind of supports all the major deep learning frameworks, make them very easy for you to deploy without actually AWS and deep learning Amazon machine images there, which is available for Amazon Linux and Ubuntu, so that you can create managed automatically scalable cluster of GPUs for training and inference and scale. And the best part, it comes pre-installed with technologies like Apache MXNet, TensorFlow, Cafe2, and kind of auto-populate your machine learning softwares like the Anaconda package for data science. And that's something which is how it's going to happen. And almost all industry domains are now innovating with AWS AI. For example, for fraud, .NET uses Amazon Machine Learning to support its machine learning models. And the company uses DynamoDB and AWS Lambda to run the code without provisioning and managing servers. So fraud.net also uses Redshift for data analysis, and there are obviously a lot of benefits from this setup. I mean, fraud.net launches and trains the machine learning models in almost, I would say, half the time it took on their platform. And it reduces the complexity and makes sense of emerging fraud patterns, which saves customers about $1 million each week. To summarize, you can create an impact in your business by automating the repetitive and manual tasks, engage your customer, and probably optimize the product quality using AI. And I hope you've learned something on this part of it, and that's something which is there. So this is an important thing, and that's how your AI kind of operates there. Now, our focus obviously is going to be on the concept of machine learning. We want to say that what is machine learning in the general and how this really operates. So when we talk about this on the machine learning, it is so as you also remember, we did say that machine learning is a subset of AI. It's a subset of artificial intelligence, and it helps you to use historical data to make the better decisions there. And machine learning is also a process where machine takes the data, analyze it to generate prediction, and use those predictions to make decisions. And those predictions will generate the results, and the results are used to improve future prediction. So machine learning can make predictions for huge data sets. It can also optimize utility functions and extract hidden patterns and structures from those data sets by classifying it data, which allows a software program to kind of learn and make predictions in the future eventually, which will eventually help you to kind of get the job done. And that is something which is a great way to get started. So on this side of it, what happens there, that your machine learning allows you to establish what I would call a cycle of improvements using the data you would collect from things like clickstream and purchases and likes there. And machine learning is used in a number of ways across a number of industries. For example, it can be used to detect fraud transaction. And if I have to kind of draw a fraud transaction view for you, let's say you have, let's say, a lot of data, let's call it as mine data, then you will identify the patterns and create labels. And what you will do from this, you will train the model. And once you train a model, you will be able to put ML in play. That means you will be able to flag a transaction as fraudulent. And that's how it's going to operate in the capacity. So for example, as I said, we can use it for fraud and transaction. We can use it for filtering the spam emails or flag suspicious reviews, a lot more there. And what you begin by mining a large amount of data to identify the patterns among the card transactions. And with these patterns, you can then train the machine learning model to flag the fraudulent transaction. It can also be used to personalize the content for users by recommending the content and a predictive content loading there. And machine learning can also be used for targeted marketing and matching customers with offers they might like, or choosing marketing campaigns and cross-selling or upselling items there. So machine learning can also be, I think, used to automate categorizations of documents, like matching a hiring managers and resumes by learning to understand written content. It can be used in customer service to provide predictive routing of a customer emails based on the content in the sender, as well as social media listening capabilities. So machine learning systems discover these hidden patterns in the data, use these patterns to predict the patterns in the future. For example, let's say if you are analyzing retail data and a product name contains words like probably jeans or jacket, then this product category likes to belong to a paddle there. So machine learning system learn from examples in the same way that children learn for language of patterns. It can group data into a summary, and then it can define data in a more granular, concise way. So think of machine learning like a combination of methods and system, and these methods in system predict new data based on an observed data, extract hidden structure from the data, summarize that data into a concise description, or probably optimize an action given a cost function there. So the field of machine learning is normally classified into two broad categories. So we will call at a supervised learning, and there is unsupervised learning. Now what happens there, and then there's also called as, I would say, reinforcement. So machine learning can categorize into three categories: supervised, unsupervised, and the reinforcement. And you know what, I'm going to make it a better way because I have to make a couple of more drawings. So let me do that real quick. So what you will, come on, where did the screen go? Let's put a wide screen there. Oops, why is it not coming? So if I have to do this, let's say we have machine learning on the top, and on the left we have unsupervised, we have supervised, and we have the reinforcement. And the supervised has a couple of other categories we call as classification, and there is a regression, and that's how it has to operate. So what happens there, if you look at these set of example there, so you can say now the field of machine learning is classified into these broad categories: supervised learning, unsupervised learning, and reinforcement. And in supervised learning, what happens if I talk about just supervised? So the inputs to the model, including the example outputs, are known as labels, and we know them already. Like what I want to really do, I know them in that side of it. And and the model kind of learns to generalize the outputs from these examples. In unsupervised learning, what happens? The labels aren't known there. When I say labels, like my hair, my face structure, or the beard, I don't know these labels. There's no way to supervise me. So if I have to say, figure out if it's a cat, I have to give so many cats as an image and label out that a cat has an ear, a cat has a nose and a mouth, and then the machine was going to take that. That's called supervising. So it's supervising that. So you are in unsupervised, you don't have. So the model finds the pattern in structure from the data without any help. And in reinforcement learning, what happens? The model learns by interacting with its environment and learns to take actions to maximize the total reward in that case. And in supervised learning, the input to the model in the example outputs are kind of provided, and the model learns to generalize the outputs from these examples. So the human teacher experience is used to tell the model which outputs are correct and which are not. This doesn't mean that the teacher has to be physically present, only that the teacher's classification needs to be present. With the help of a large training data set, what happens that the model learns from its error and changes its weights to reduce its prediction error. And in the classification, the output variable is a category. Let's say it's a color, which would be red, blue, or green, and it results is going to be true or false for a particular question. In regression, the output variable is going to be a number or a value like a weight, like a dollar temperature. And in unsupervised learning, which is also called a self-organization, there's no teacher. It based solely on the local information. So in this case, in unsupervised, the model uses only the data presented to the network without any labels, and it detects the emerging properties of the whole data set. So what happens is unsupervised, the model then constructs the patterns from these available information without any pre-trained data. And in a clustering, the model discovers these groupings in the data, like grouping customers based on their purchasing behavior. And in association with that, the model basically discovers the rule that governs the large chunks of data. For example, customers who buy a product A kind of tends to buy product B. And eventually in the reinforcement learning, there's a software agent that determines the ideal behavior within a specific context for a particular problem. So the agent takes the input and decides the best action for the problem, and then based on the result of the action, the agent then receives simple reward feedback to allow it to learn from its behavior. So the agent is encouraged to select an action that maximizes the reward in the long term. And this type of machine learning algorithm is inspired by behavior psychology. Part of getting useful information out of your machine learning system is having a smart application. Your smart application will use machine learning to analyze your data, predict future outcomes, which I would say are necessary to make business prediction. I'll tell you a simple example. I'm sure a lot of you use Google Photos on your phone. Have you ever observed that when you use Google Photos kind of does this, tweaks already for the images, enhances them? How do you think Google does that? Google does that with the help of its inbuilt machine learning and that smart application there. And that can include machine learning using for your business questions like predicting the customer trends, like whether customers will use a particular product of yours, or to determine if an order is fraudulent. And based on the customer data you already have, you can find patterns in the data and then generate predictions to drive your product features and improvements. While machine learning is a rapidly growing field, I would say, with an enormous upside for companies to use, there are some challenges to take into consideration when you're building a machine learning based smart application. For instance, I would say some machine learning technology can be complex to use and implement appropriately there, so requiring high level of expertise, which can take a lot of time to hire or develop. And one more challenge is to finding the right technology that scales to the need of your customer or probably yourself. And finally, I'd say being able to tie machine learning to a business application can lead at time. So refining your models so that your product app can use that model productively could require a lot of time there. And I would say these are the three primary considerations you should take in account when you're building your machine learning application. And one way to help address these challenges could be Amazon machine learning. You would say, hey, Vishal, you take a lot of time to sell this product, and that's not the case. And that's why we kind of use the Amazon machine learning as an offering. Now, I said before, we're offering machine learning and Spark on the Elastic MapReduce or EMR for customers who want to manage platforms for building models using their own data. For developers and data scientists who want to focus on building models, the platform services removes this undifferentiated overhead associated with deploying and managing infrastructure there. So if I have to show you this quickly, AWS Machine Learning, let me quickly bring something for you on the screen. So if you look at the AWS Machine Learning offering, you'll be surprised to see that I'm going to have something on the screen that we have so many use cases. You can see we have now, these are the services that I was talking about. So there's so many offerings, as you can see, kind of happens to come here from different machine learning offerings. We've got SageMaker, and then there are the services that happens there. There's intelligent search there, there's personal documentation, there's Kendra, there is text track, comprehend, translate, metrics, forecast, detector. If you look for vision, panorama, recognition I was talking about, there's Lex, there's Transcribe, there's Poly, there's DevOps Guru, there's Code Guru Reviewer, Profiler. For industrial part of it, there's Monitron, there is Lookout for equipment, there's Lookout for vision, there's Panorama again, and there's Panorama appliance for healthcare. You've got Health Lake, you've got Comprehend Medical, you've got Transcribe Medical. So you can say that we've got so many services that happens there. And then to get hands-on machine learning, we have things like Deep Racer, so you can run reinforcement learning, which I just explained to you. You've got Deep Lens, which is about a great way to start with the computer vision, and a Deep Composer, so you can generate AI using a musical keyboard. You can tell AI what you need to do there. So with Amazon, you can say that 89% of deep learning projects in the clouds are on AWS. So we can imagine how great they are. And then you increase the productivity by 10 times, and there are hundreds of algorithms which are there in the market already to use that. And we have this Deep Racer League, which is a great concept, the competition that you can happen to have there, and you can build your robots and give them, train them, and they will be part of this Deep Racer League. And let me show you a quick example of this.
AWS Deep Racer League.
Oops, that's so you can look at this.
All skill levels can get hands-on with machine learning.
I'm not sure if that happened there. So what happens with this, as you can see, in this Deep Racer League, what happens as an individual, you define your bots, and those bots will go in the finale. And there's a virtual bots, and then you will start learning them. So you can host a live race, you can look at the division, you can build your cards, and you can see there are leaders who are kind of doing this part. So the better you train your bot here, the faster it's going to build that. So you can imagine that Amazon offers you so many services which can help you to get the start done, and there kind of has to move in the direction. That is exactly how Amazon does machine learning. So when you look at this whole process, I mean, you can now understand that AWS provides a robust cloud-based service, and we call it as a SageMaker, which is there on the market. As you can see, SageMaker is a service. Now, SageMaker is there to help developers of all skills to use machine learning technology. And SageMaker is a fully managed machine learning service which helps you to create these powerful machine learning models. So with SageMaker, as a data scientist and a developer, you can build and train your machine learning models and then directly deploy them into a production-ready host environment there. And that is exactly what SageMaker Amazon Machine Learning does for you. So if you look at some of the Amazon machine learning concepts to understand how they kind of happens to exist there, the first thing you can see is a data source. Now, data source is an object that contains the metadata about your input data, and Amazon ML reads your input data, computes the descriptive statistics on its attributes, and store those statistics along with a schema and information. And as a part of data source object, you kind of get this. And then your Amazon machine learning uses the data source to train and evaluate a machine learning model and generate their batch prediction there. And that's something which is a part of this. Then you have these ML models. So your ML model is a mathematical model which generates a prediction by finding the patterns in your data. And Amazon supports 3 types of ML model. There's a binary classification, there's a multi-class classification, there's regression, and we have spoken about what these mean there. Regression means the goal of regression training is to predict a numeric value. The goal of a binary ML model is to predict values which can only have 2 states, like true or false. So if it's a cat or not a cat, that's a true or false. And a multi-class can have multiple values, so you can even define there. Then you have evaluation. Evaluation measures the quality of your ML models and determine if it's performing well there. So you get the model insights, you get the area under the curve there, you get the root mean square error, a metric to evaluate the predictive performance of your model there. You have accuracy, precision. All these are the evaluation metrics there. Then you have the batch prediction, which are the set of observation that can run all at once. And this is ideal for predictive analysis that do not have a real-time requirement there. So you can even have there, eventually, we have these real-time prediction. Now, real-time predictions are for the application with a low latency requirement. So if you're looking for an interactive web application, desktop application, you can use these real-time prediction APIs, which accepts a single point input observation, the request, and kind of helps you to get the responses from there and kind of get moving there. So that's something how you can actually leverage that as a process and kind of move in that direction. And you can access the Amazon machine learning from the console, from the CLI, from the ML API and SDKs. There are so many ways to do this as a process. And you have machine learning services in different regions there. That's, I think, North region, Ireland are one of the regions that can happens to exist there. So when you look at these process, you can understand that this is kind of happens to work there, and this kind of happens to exist. Now, if you look at some of the machine learning concepts, machine learning helps you to use historical data, as you can say, to make those business decisions there. And there are different patterns in the data and construct that model use these discovery there. And you can use these models to make the predictions on the future data. For example, one possible application of machine learning would be to predict how likely a customer is to purchase a particular product based on their past behavior there. So what you want to do, you want to solve a business problem with the Amazon machine learning. So you can use the Amazon machine learning to apply machine learning to the problem for which you have an existing example of actual answers. For example, if you want to use machine learning, Amazon machine learning to predict if an email is spam, you will need to collect email examples which are correctly labeled as spam or not spam. And you can then use the machine learning to generalize from these email examples to predict how likely a new email is going to be a spam or not. And this approach of learning from data which has been labeled with the actual answer is now known as supervised learning, because we have given the data for the system to learn, and from that data is going to respond to the future answer there. So you can use a supervised learning machine learning approach for these specific machine learning tasks, which is a binary classification, there's a multi-class classification, there's regression. So if I give you a binary classification example, think like, will the customer buy this product or not buy this product? That's a yes or no. Or the email spam or not, yes or no. If it's a product, a book, or a farm animal, yes or no. Is this review written by a customer robot? Yes or no. That's binary classification. If I talk about multi-class classification problem, think about, let's say, is this product a book, movie, or clothing? That multiple, more than one answer. Is this movie a romantic comedy, a documentary, or a thriller? That's a multi-class. Or which category of product is most interesting to the customer? Multi-class. And regression would be, let's say, what would be the temperature in Seattle tomorrow? Or for this product, how many units will sell there? Or how many days before the customer stop using the application? Or what price maybe this house will sell for? So you have to solve the business problem using the machine learning. That's the first segment that we have to focus on, can do this. Now, once you have a use case, then you have to be careful about, when do I use a machine learning? When do I really leverage the machine learning after the use case? So it's very important for you to remember that the machine learning is not a solution for every type of problem. You can't just put machine learning to anything. There are certain cases where robust solutions can be developed without using ML techniques. For example, you don't link machine learning to determine probably a target value by simple rules or computation there, or there's some predetermined steps which can be programmed without needing any data-driven learning. So you can use machine learning if you cannot code the rules. So if your solution or problem cannot be solved with a rule-based decision, you can't really do that. For example, the email spam example, we have to use machine learning because a spam category could be anything. Probably as email has some obscene words, that's a spam category. So you can't write a rule for that. Probably an email has got some marketing content. Now, marketing content could be anything with that. That could be spam there. So you can't have one rule, because if you have different categories for spam, you could have to write thousands of rules. So if you cannot code the rules, use machine learning, because a lot of human tasks like recognizing whether an email is spam or not cannot be adequately solved using a simple deterministic rule-based solution. So a large number of factors could influence the answer. So when rules depends on too many factors and many of these rules overlap or needed to be tuned very finely, it soon becomes difficult for a human to accurately code the rules. So you can use machine learning to effectively solve this problem. And once more thing would be if you can't scale. So you might be able to manually recognize a few hundred emails and decide whether they are spam or not, but this task becomes tedious for millions of emails. So ML solutions are effective at handling a large scale problem. So you have to be careful and be great in terms of when you have to build, when you have to use machine learning. And when you realize that, okay, now I have to use machine learning, then you have to start building a machine learning application. So what happens in that as a process, now building machine learning application, I said before, it's an iterative process that involves a sequence of steps, I would say. So one, you have to frame your core machine learning problem in like, what are you going to observe? What is the answer you want that model to kind of give to you? You want to collect the data, you want to clean that data and prep the data to it can be consumed by the machine learning model training algorithm there. And then you want to visualize and analyze the data to run the sanity checks to validate the quality of the data. And I have seen a lot of time often the raw data and the answer not represented in the way you want us to live there. So you have to give the model the right set of data, feed the resulting features. So what I want to do, I want to know whether email is spam or not. So I will feed those resulting features to the algorithm, which is going to use as a learning algorithm to get the model to give me what I want there. And then eventually what I would do, I would modulate, I will use the model to generate these predictions of the answers there. So remember, formulating a problem is first thing. And once you're able to formulate the problem, you have to decide whether I have to, what I'm trying to do that. And that means you need to know your label or target answer there. I mean, think about a scenario. Let's say you want to manufacture products, but your decision to manufacture each product depends on its number of potential sales there. And in that scenario, you want to predict how many times each product will be purchased. And there are multiple ways to define this problem by using machine learning. So choosing how to define a problem will depend on your use case or business needs. Probably you want to predict the number of purchases your customers will make for each product, or do you want to predict which products will get more than 10 purchases there? All these things there. So it's important for you to avoid overcomplicating the problem, but formulate the problem in the right case and then collect the label data, because machine learning problem starts with the data, preferably loads of data for which you already know the target answer. So data for which you already know the answer. And if I know this data is spam or this is a product we have, so the data you have an answer, that's what we call as a labeled data. So in a supervised machine learning, the algorithm teaches itself to learn from those labeled examples that you provide there. And you kind of move there. And once you have the data, you are going to analyze the data. So before feeding your labeled data to a machine learning algorithm, it's a good practice for you to inspect your data to identify the issues and gain insights about the data that you're using. And the predictive power of the model will be good as the data you feed in there. So that's again, which is there. So once you have the data, you labeled it, you kind of collected that, you analyze that, and you want to do a feature processing. So once you get to know your data about, let's say, summaries and visualization, you want to transform that data to make them more meaningful. Like, I want to do a feature processing. Let's say you have a variable that captures the date and time at which an event occurred. So this date and time will never occur again, and hence won't be useful to predict your target. So if this variable is transformed into a feature that represents the hour of the day or the day of the week or the month, then these variables could be useful because that can happen eventually. The event can happen there. So you have to do a feature processing. And once you have the feature processing done, you want to train the model. So the whole process on the Amazon side of it is to train the model to get the job done. And that's a very important thing, that you have to have these models there. So there are different kinds of models that Amazon provides you. So once you're ready to provide the ML algorithm, the learning algorithm with the training data, the algorithm will learn from the training data patterns which map the variables to the target, and it will output a model that captures these relationships. So the machine learning model, it can be used to get the prediction on new data for which you don't know the target answer there. So you can actually leverage this as a model there. So there are different kind of models. So you have a linear model. So there are a large number of ML models, and Amazon machine learning learns one type of model called a linear model, which implies that the model is specified as a linear combination of features. So based on the training data, the learning processes compute one weight for each feature to form a model that can predict or estimate a product. So for example, if my target is the amount of insurance a customer will purchase and your variables are age and income, then a simple variable income, you can just write an equation that kind of gives you the answer there. So you can have this as a model there. Then there are learning algorithms. So these learning algorithms task is to learn the weights of the model. So the weights describe the patterns that the model is learning, reflect the actual relationship in the data, and your algorithm is going to consist of what we call as a loss function and an optimized technique. So you will use that to build a model there. And you want to kind of get started with this whole process to kind of build a system around this as a model. And then you will have these parameters and kind of different accuracy model to kind of do this job here and kind of get the option. So you have so many ways to kind of do this process. And when you're training ML models, there's so many ML models that kind of happen. So there is a binary classification model, there's multi-class model, there's a regression model, and once you have these models, you have to process them. So to train them on an ML model, you have to specify the data source of the training and what is the attribute there, what's the required transformation there, what are the parameters there. And these parameters, so typically machine learning algorithm accept parameters which could be used to control certain properties of the training process and of the resulting ML model. So in Amazon Machine Learning, these are called as training parameters there. So you have to put in the training parameters. And once you do this, you have to create an ML model. So once you have got a data source, you're ready to create an ML model. And if you use the Amazon Machine Learning console to create a model, you can choose to use a default setting, or you can customize your model by applying those custom options. So a lot of things kind of happens to exist there and kind of get the job done. And that's something which is absolutely a great way to kind of move in that direction. So you can understand that how this happened, and you can see that data transformation is a great aspect on this product, because machine learning models are only as good as the data that is used to train them. And one of the key important thing of a good training data, that it is provided in a way that is optimized for learning and generalization there. And the process of putting together the data in its optimal format is what we call as a feature transformation there. So obviously, if you look at the feature transformation, consider a machine learning model whose task is to, let's say, probably decide whether a credit card transaction is fraudulent or not. So based on your application background knowledge and data analysis, you might decide which data field features, the field I'm talking about features, are important to include in this input data there. So you want to leverage them as an option there. And for example, the feature would be a transaction amount, or who's the merchant name, probably the address, or the credit card owner's address. All are important to provide in the learning process. And on the other hand, a randomly generated transaction ID carries no information. I mean, if we know that is really a random, there's no useful. So once you've decided on which fields to include, you transform these features to help the learning process. You can say that the transformation kind of adds the background experience to the input data and allows the machine learning model to benefit from that experience there. And obviously, there are different ways to transform the features before creating machine learning models with Amazon ML. You can transform your input data directly before showing it to Amazon ML, or you can use the built-in data transformation of Amazon ML. So you can use whatever feature transformation with the data recipes that kind of happens there and kind of do this. And Amazon machine learning recipes, they contain instructions for transforming your data as a part of the machine learning process. And there are these recipes that are often defined as JSON syntax, but they have additional restrictions. You can use these recipes to kind of define your job and kind of move in there. And if I look at some of the subjects, or talk about some of the subjects to repeat, let's say probably you create a new data source in Amazon ML, and the statistics are computed for that data source. Amazon ML will create a suggested recipe that can be used to create a new machine learning model from that data source. And this suggested data source is going to be based on the data and the target attribute present in the data, and provide you a useful starting point for creating and fine-tuning a machine learning model there. And in terms of data transformation, you have so many references there. You have an n-gram transformation, you have an orthogonal sparse bigram, it's called OSB, you have a lowercase transformation, quantile binding transformation, normalization transformation, so many transformation there. So once you do the transformation, you do the rearrangement, which is a functionality which allows you to create a data source which is based on only a portion of the input data that it points to. So let's say if you create a machine learning model using the create model wizard in Amazon ML and choose a default evaluation option, Amazon ML will automatically reserve the 30% of your data in ML model evaluation to kind of gives you the right aspect. So you kind of have to define this. And once you're able to do the data transformation for this, you have to evaluate the model. That means you should always evaluate a model to determine if it will do a good job of predicting the target on a new and future data, because the future instances you have unknown target values. So you need to check the accuracy metric of the ML model on the data with which or for which you already know the target answer. and use this assessment as a proxy of the predictive accuracy in future data. And to properly evaluate a model, you hold out a sample of data that has been labeled with the target ground truth from the source, and then evaluation becomes easier. And there are so many ML model insights that can be used there. So when you evaluate a machine learning model, Amazon Machine Learning provides you an industry standard metric and a number of insights so you can review these predictive accuracy there. So you get these binary model insights, you get these multi-class model insights, you get the regression model insights, you get cross-validation, you get evaluation alerts, you get a lot of these evaluation for the machine learning model to kind of get started and kind of get the job. So this is a very, very important thing. And once you do this, you will be moving in that specific direction to kind of get a job done. So as you can understand, that machine learning is something that kind of happens to exist in a way that you will be able to build a system around this and kind of have those system to do the job for you and do this thing. So machine learning is a huge process where you can kind of do this as a service and kind of get a job done. So I'm going to talk about a couple of services with you while showing you the actual pages so you know what I'm referring there. So let's look at a service here, probably for now. There are services which I think are really important to know. So let's look at recognition for a moment there. Now, if you look at recognition as a service, it's a great effort of that. So recognition is one of the AWS offering in artificial intelligence. Now, recognition allows you to easily analyze images. Your application can make calls to the recognition, allowing you to recognize faces and landscape and even the mood of a person. And so once it happens, there's you can actually kind of use to kind of get a job done. And the main benefit of the recognition are its ease of use as well as its low cost. So with a zero experience in developing machine learning, you can actually load an image into recognition and it will be analyzed automatically, and you can take advantage of the APIs we have created to automate this analysis. And best of all, as a managed service, Amazon will handle auto scaling of the recognition, allowing you to potentially send thousands of images an hour for analysis through the recognition there. So the key feature of the recognition are the object detection, where the engine is able to accurately determine what isn't an image, maybe a facial analysis or facial comparison, all the facial recognition there. So it's a service, as you can see there, which kind of helps you do all these jobs there. And the engine is able to determine even the number of faces, and it will be able to differentiate different faces from each other. And all these process images gives you a confidence score there, giving you the ability to drop a low confidence processes or perhaps flag them for a secondary or even a manual review. So if I talk about some of the use cases of the recognition, and here I hope to kind of show you how useful and powerful the service can be for your application. So searchable image libraries could be one thing which could be useful for many cases, like a real estate agent looking to take a picture of a property. They can upload this to an S3 bucket, then this upload image will trigger a Lambda function, and the Lambda function will call the recognition, which pulls the image from the bucket and analyzes this image and returns the image and labels along with the content score for each labels into Elasticsearch. So users can now search through the labels to find the images, which makes the searching for keywords like a garage or probably a yard far easier for any real estate application there. One more use case would be image moderation there. Now, this functionality can greatly assist foreign moderators, ensuring that inappropriate content is not posted there. As a user uploads an image, the object uploads triggers a Lambda function. Lambda calls the recognition, which examines the image for the content. If there's no inappropriate content found, the picture is immediately posted and viewable by users. If there is inappropriate content detected, the post is either rejected and the image is removed from the storage. And if the content scores are not high enough, either way, it can also send the image for a manual review, ensuring that only the approved content is shown there. And then there is sentiment analysis also, I would say, which could be quite useful for a lot of users there. So from retailers wanting to track the effectiveness of sales or demographic information of a shopper to a company that just want to ensure that their workforce is happy, live images are captured via this on-prem camera, or a user upload the images. The application will send the images to a recognition for analysis. The app stores information in S3, and the Redshift will allow them to receive this data in, and then we can use QuickSight that can be used for regular analysis of the information, tracking the sentiment over time, and all the information can be placed into a weekly or monthly or even a quarterly marketing report to track the effectiveness of your ongoing soldier or upgrades to the stores or just changes in your overall merchandise over time. So that is something which is there to kind of do this, and this is a great way to kind of do this. So let me give you a small recognition demo of how recognition kind of helps to work there. So I'm going to quickly log into my console of Amazon to show you how this sweet feature operates there. So let me kind of do this and show you real-time stuff about the recognition as a service. Okay, so you can see this is my console. I'm sure everyone is aware about what console is on AWS. This is where you kind of do everything that kind of happens to exist there, right? So this is where the whole beautiful thing happens there. So we're gonna go ahead and load the recognition service. And to do this, what I'm gonna do, I'm gonna search for the service. I'm gonna type it RAK. You can see Amazon recognition as a service is there. And if you have recently visited, it would have been there. So you can see the service is there. And there are different ways to get a service. I mean, you can even get a service right from this place. There's so many action as it there. So you can access recognition using its APIs to analyze your images. Also, you can download the SDK and run your programs or write the program that utilizes the recognition. I'm just going to try the demo to the recognition, so highlight how easy it is to analyze your images there. So in this case, as we pull up the recognition, as you can see, we have some stock images that are already loaded into this. And on the right, you kind of see the results. You have the labels as well as the content score for each label. As you can see there, they're in fact a skateboard. There's people image on the side of road. There's a part of it. So you can see we want to expand this more. As you can see, we have more option there. So you can see that it's in fact on the road all the way down to in the metropolis. There's SUVs and there's apartments. So there's a stock image, right? Let's go ahead and try to probably upload an image of our own. Maybe let's do something here. I'm gonna download, let's say, Seattle images. Just Google it. So let's do this. Let's say I like this part. Let's save image as, save image as, and save it. Now we go to console, and in this case, we're gonna upload our own image. You can see this is the image. And the moment I did that, as you can see here, our labels found are the urban, city, town, building, high-rise, architecture, metropolis, downtown, neighborhood, skyscraper, apartment building, office building, outdoors there. So there are multiple high rises you can see there. So that kind of there, in fact, this is a metropolis. So this image is fairly easy to kind of give the recognition. So you can say Amazon recognition is able to do that job for you to kind of do this as a process. Let's use one more image. Let's say use an image with something more. Let's say we use people. Okay, and let's say I want to use actually multiple people. Come on, I'm writing bad spell here. So let's say we use. I'm trying to use something a more. I think if this looks high definition, yeah, this looks fine. Let's use this one. Saving this image again, and we're going to use the recognition to upload this image. So we have people here, and it's going to. So you can look at this now. Beautiful thing. This is multiple people in here. On the right side, we have people, we have human, we have clothing, we have apparel, we have female, we have blonde, we have teen here, we have a kid is not there, so that's the wrong thing. So that's the one thing which is there. So we can use this as an option there. So that's one thing. And if I'll give you one more example, so you can see we are detecting a face also, but just let's say a face here. Let's say I'm going to detect myself. If I just write my name, I'll find so many things off my side. So that's me, and you can see there's so many pictures of mine that's going to come here, but use this one for a moment. save images, put in here, use load. Let's see what it says there. Clothing, apparel, suit, overcoat, coat, person, human, yes, I am, man, yes, face, yes, blazer, yes, jacket, yes, portrait, photography, photo, beard. It's able to get my beard there, so you can see how great is this as a service there. So this is so we are kind of loading in there. You can see there that's kind of get the job done. So if I do the same thing, if I go back again, upload the people image, now you will see that it's able to recognize the person here instead of this. So it's not able to recognize faces. But if I kind of do a more zoomed in image, maybe let's say, so let's okay, that's not the one. Oh, that's a lot of me there. Let's use multiple people. So just to show you this as a process here, probably something close. I want to detect some faces there. Probably, let's see. Close faces, people. Well, I'm trying to look stupid here right now. Probably this. Well, let's see what this image does. Maybe save image as. Let's use the recognition to do this. If I use this image, let's see it now. Yeah, you can see this is able to recognize the faces of everything. So you can see this is what I want to show there. So it's able to pull and highlight where the faces are, and if you can look at this, there's also a celebrity recognition. So you can see if this person is a celebrity. So you can see that's Jeff Bezos, for example. So you can use this as a celebrity, and I know a person who could be a celebrity. I don't know if it's going to consider me as a celebrity. I don't know. Let's see that. No, that's very bad. It says no celebrity recognized. I'm going to use my brother's name. So I have my brother is a celebrity, so I'm going to use his name. So he's my brother. He's a celeb here in India. So I'm going to use his face and see if this recognizes him. Let's see. Oh, wow, that is so weird. Brother's not recognized there. Maybe it's not taking all the images there. Okay, let's see. Let's use probably Amitabh Bachchan. So that's all of our favorites, right? I hope it's able to get Amitabh Bachchan for us to recognize. Let's use Mr. Amit Chi. And please give me a celebrity face this time. Come on. Yes, at least we got Amitabh Bachchan as a celebrity. Second, there's also a great feature of this. So this is one of the cool features about this. So I think it's taking data from Wikidata. So recognition, quite easy to do this. There are multiple demos you can do get this. There's face comparisons, and there is text enlarge. So there's text in image. So there are a lot of this to kind of do this. So if you do this, a detection there, probably use this and use this here. Let's see if we can compare and lie something. So it says there's no result, nothing is matching there. But if I upload an exact image of this here, it will compare it exactly. Similarity is there. So let me give you a simple example. Let's probably use this image. Let's see if it can figure out Mr. Amit from the old school days. Upload, and let's put it here. Let's see what happens this time. Oh, wrong image. This one I wanted to upload, please. Why it's not taking my image? Upload. Open. So weird. Let's upload. God knows what's happening here. It just somehow gone crazy on this. So let's use this image. Use this image, and let's see. Oh, image needs to JPEG format. What format is this? Oh, could be. Yeah. I think it's because of the formatting there. Probably I'll download something else. Maybe this. I'm sorry, I'm just doing this right now. I have no JPEG. I think that's full take here. So if you use this, probably for a moment. Yeah. So let's see similarity this time. It's going to tell us similarity. Yes, 99.1%. So you can see that recognition is some great feature, and that's something there. So in a small summary, it's a great tool, recognition, a great tool in our machine learning offering, which gives you an ability to run multiple forms of analysis, your images, and return the labels with the confidence score to ensure that the analysis is accurate. And I hope you've learned a little something, and that's what one of the function in deep lens that perform the three important things I would say. There's this pre-processing, there is capturing inference, and there's displaying output. And once a project is deployed to deep lens, then the model and the Lambda function can run the device locally, and deep lens creates a computer vision project that consists of the model and inference Lambda function there. And there's AWS Green Grass that can deploy the project and a Lambda runtime to your deep lens, and from there. So what happens there? When you turn on that deep lens, what it does, it starts capturing a video stream. And the way it does it, it kind of produces the stream into two output streams. There's a device stream, which is the video stream passed through video processing without processing, and then the product stream, which contains the result of the processing there. So if I kind of show you, probably there's a document somewhere which kind of shows me the tech specs for this. So this is the deep lens there, and let me look at some of the deep lens doc. So deep lens doc here, and I hope it shows me that picture where I can quickly show you a piece of that. Come on, there's a developer guide, and if I go here, how deep lens work. Yeah, so this is the part. So this is the picture I was talking about. So if you look at this picture, and if I kind of open the image in a new tab, this kind of gives you a bigger view of it. Okay. So if you look at this picture here, this picture shows you how the services kind of come together. So first, when you turn on the deep lens, as I said, which is the video stream, the video stream is going to pass through without the processing, and then the product stream, which contains all the results of the model processing video frames. And from there, the inference Lambda function will receive those unprocessed video frames and passes those unprocessed frames to the project's deep learning model for processing. And finally, the inference Lambda function receives the processed frames back from the model and passes them on to a project stream. Now, we don't really see this in the diagram, but deep lens is well integrated with other services. For instance, if a product is deployed to deep lens, it is securely transferred over the green grass, and the output of deep lens when connected to the internet can be sent back to the console by AWS IoT and Kinesis video stream. So you are kind of there. So it's a great service to kind of does the entire inference process and kind of do this as a model. So this is a beautiful service which kind of happens to exist for you, and you can leverage that as a service, kind of get a job done. Now, there are a couple of other services that I want to address in this case. So this is deep lens, and we can't give a deep lens demo because deep lens is a hardware-enabled service. So I'm gonna close that, and we're gonna go back some of other services. So one service that I want to also show you is there's a Comprehend. So COMPRE. So there's Amazon Comprehend. Let's look at the service. Now this is Comprehend. Now, when we look at this service, again, a great service, I would say, in terms of NLP, and that's again a beautiful feature about this, and kind of do this. Now, let's see, why am I talking about this service in general? So it's really important for you to understand that the unstructured text, so that text is actually not a schema. So we have text that's not a schema, it's not a relational table, it's frankly exploding, it's growing exponential, right? So if you think about the 70s or 80s or 90s, a lot of us were inputting information into computer systems in a structured way. Now there were forms, we were writing them through data input, a lot of like Excel, and this information was coming in structured, and it was therefore being stored in a structured way. And that means that there's a set of technology that we've built to allow us to store and query that as a structured data. And now we're entering an era where a lot of information being generated is unstructured. So you can think of things like social media, and you can think like Twitter, you can think of the way your brand company or services interacting with your customers. So those customers are feeling like with the chatbots. They're interacting with you in conversational ways. They're interacting with your brand or services in comments and reviews. And this is all the data that's important and is growing exponentially because it's easier to communicate that way. And more people will continue to do that. Value is logged inside of the text. So to a machine, it looks like a string of unstructured text. To a brand manager, it looks like what somebody's saying about their price or the experience they had staying at a specific hotel, or maybe in fact that they stayed somewhere that they really enjoyed the coffee shop down the street. And these are all the elements of information that are important to any business or really anyone. So the reason why we're able to bring something of high value like this today, it's because of that machine learning and artificial intelligence. Now, text analytics and natural language processing specifically has been around for a while, but it's really been rule-based, which allows you to parse unstructured data. So you can do things like keyword counting and sorting. And now with deep learning models, you're able to train this technology to bring human-like context and awareness. And to the text extraction, to that NLP experience is also there. And the last thing I want to mention that's really important is that I've thought deeply around how to, put this together. But so understand, so it doesn't really require an advanced skills set or like a 3-month exercise. So when you learn about models deeply, you learn about training models. And this service specifically is brought so that everyone that works with data today can work with them. With the skills you have today, can now look at approaching the natural language processing. That's AI based. So using the skills that you have is this processor. And that's what the component is all about. So the service, it's often give you, I think, about 5 main capabilities. And it's important that you know these capabilities, which are based on the deep learning. So one of the capabilities of the comprehend is sentiments. And if I kind of go this as a model here, and let me show you a couple of comprehend features for you to do this. So you have, we have these capabilities on the left: key phrase, sentiment analysis, syntax there. So the sentiment allows you to understand whether what the user is saying is positive or negative or even neutral. Sometimes it's important as well. And you want to know if there is not sentiment, that might be a signal. And then there are these entities, for example, that actually categorizes them for you. So things like people or things like organizations will be given a category. And there is also this language detection. So for a company that has a multilingual application with a multilingual customer base, you can actually determine what language the text is in. So if you have to translate the text itself or probably take some other kind of business actions on the text. So that's one thing. And the fourth capability is the phrasing there. So you can have the phrasing as a model there. So key phrasing is also one of the important things that you're going to happen there. So you can have multiple language support there. So you have a support for those of these offering and modeling. So you can, the topic modeling is also one of the great thing, which works with a large corpus of documents and helps you to do things like organize them into topics which are contained within those documents. So it's really nice for organization and information management in the case. And if I talk a bit deeper around the APIs that help you text analysis, so you can actually have a snippet of unstructured text. This could be like a comment, let's say, or it's mentioned somewhere, and you can have the APIs to extract the named entity, like let's say Amazon.com, from that as an organization. Probably you can get the name of the city, maybe in the comment mentioned as, let's say, Seattle. You can extract the noun-based phrases or things like everyone, like a great customer experience kind of stuff. So there are a lot of things that you can have even in sentiment analysis there. So in generality, it's a great service that kind of happens to get the job done, and then that's something there. And this modeling that I'm talking about, so topic modeling is something Amazon have done, and they've done topic modeling as a service. So for those who aren't familiar, topic modeling is doable today. It's based on an algorithm called as LDA, which is latent dirichlet allocation. And it's been kind of hard to get set up. So you have to go find an environment. There's a lot of parameters to tune. You have to obviously deploy and operate that environment to run that algorithm. And Amazon team has done a lot of heavy lifting to make that algorithm available to you as a simple API. So you can think about topic modeling as a service. So you can just walk up, bring your document, start using that. And this service works up by extracting up to about 100 topics. So, and when I say topic, a topic is like a keyword bucket. So you can use, you can see what's in the actual corpus of the document itself, and the service also returns to you an automatic view which maps the documents to topics. So to give you a really basic use case, you can take 1,000 blog posts, understand what's in the blog post, and from a top 100 topic perspective, you can do that, and then actually map all the blog posts into the topic bucket. So if you wanted to give your users a really easy way to explore or browse your blog post based on the topic they're interested in, you could do that with a simple call to this job and the job service itself. And that's one thing. And another important thing that really gets me excited and why this service is valuable is the NLP, which is the natural language processing. Now, NLP has been around for a while. There's a lot of folks doing NLP that's AI based. Now, what Amazon have built here today is a service that's truly accurate. Now, Amazon has an engineering team and a data science team behind the service, continually working nonstop to make the service accurate. And on day one, you'll notice that this service is accurate out of the box, and it's in its competitive domain, and it's useful for that accuracy that you need for use cases that you're dependent on. It's continuously trained. So I've said there are folks behind there, so collecting data, annotating that, training the model, looking for accuracy problem, fixing them. Amazon is doing this continuously nonstop. So the more you use the service, the more you'll be able to have the service become accurate for you based on your own data. And then based on the fact that the team is training it on your behalf, so the service gets better over time, is also a plus one. And the service is easy to use. So as opposed to understanding what a model is or how to think about training model or invoke a model, you can simply walk up and it's included in the SDK, and you can simply invoke the service. It's a REST API, and you can build the service in conjunction with AWS Analytics service quite easily. So that's something which is there. So it's a great way to kind of do this and kind of get started. And if you look in the whole process of comprehend, let me do one thing. So if I go to my console here, and if you look at, let's say, come on. So I think this is on place. So what I'm going to do is so we can't run much of comprehend, but I'm going to show you. We can analyze unstructured text here. If you look at the comprehend, I'll launch it, and you can do a lot of. You can see this is an input text that kind of happens. So this is a dummy text that you have in there, right? Let's analyze this text. You can see in this text, we're able to say that Zhangbi is a person, John is a person, any company financial service LLC is an organization there. There's a credit card account number, that's other, and then you have this amount, there's quantity, there's July 31st, that's the date, and other there, there's location, there's all these things. So we can see with just few clicks, I'm able to extract a text from here, and you're able to kind of extract this information and kind of get the pod here. And you can look at the sentiments there. So you can see it's a neutral stuff. I mean, this is not something crazy that's being written there. The key phrase, you can look at the key phrases that are happening to existing there. So you can look at the content score. The language obviously is English, that's complete there. You can look at the PI, which is a personal identifying information. You can say that, okay, this is a PI, it's a credit debit card number. So you can look at this. This is one of the great things that if you're putting some text, extracting some text, these information can really help you to get that. And there's some tag that can be used in there. So hello, Zhang, so it kind of gives you the noun phrasing there. So you can see this is a great service when it comes to the analyzing something and kind of do this. And when you do this comprehend, there's also, if I can go back here and kind of give you a read of this. Oops, sorry. So if you look at this, in this, we also have the comprehend medical. Again, a beautiful service in this case. So when we look at the whole power of comprehend medical is a set of, you can say, hyper eligible machine learning powered API that's built specifically for the healthcare domain. Now it makes it easy to extract and structure information from the unstructured medical text, and it does this with the state-of-the-art accuracy, helping the developers to build applications that can improve the patient outcomes. So Comprehend Medical makes the advanced medical and text analytics accessible to all the developers with no upfront cost. And what problem exists that Comprehend can solve? Let me tell you. So more than about 90% of the healthcare providers use electronic health records to store a patient data. And there are few structured fields in an EHR, and most of the valuable patient information is trapped in the free-form clinical text. And a simple example could be admission notes, like a patient history or a discharge note. Now, extracting value-defined insights from unstructured clinical notes is a manual and a labor-intensive process, which creates a bottleneck that slows down analysis that could result in a better health and business outcome. So you might be thinking, how does Comprehend Medical actually work? So it's an extension of the Amazon Comprehend service, natural language processing models for entity extraction for the medical text. And what it does, it leverages the deep learning to extract the entities from unstructured text in the healthcare field, like the clinical notes and radiology readings. And Amazon Comprehend leverages the latest advancement in machine learning to bring a high level of accuracy and an efficient way to extract the clinical information. So Comprehend Medical consists of two APIs. There's a near API, which will return a JSON with all the extracted entities, their traits, and the relationship between them. And the second API is the PHID API, which will return just the protected health information contained in the text. And developers can easily integrate Comprehend Medical into their data processing pipelines with tools like Glue as an example there. And you can process this with SageMaker and extract those structured data that's built around the model there. So it's a great service around this, and the data is kind of valuable there to kind of do this. So this actually kind of gives real insight. And let me give an example. Let's say a patient denies taking some medication. That medication would be negated. So we can show whether a diagnosis is a sign or a symptom. And that's important when you are working downstream. It's very important to have that differentiation in order to fit into a lot of workflows that exist with our healthcare customers. And we kind of also had a relationship in terms of extraction. So for example, let's say the test name is a platelet count, and the actual value is varied significantly. So you can use an UI to kind of get the job done. So if I kind of see this, there's a so this input text, which is kind of giving some gibberish text here. So if you analyze this text, you will be able to see something at the bottom. So look at this. This PT is 87-year-old young woman, high school ticket with a past medical history, overlaps, stress post, cardiac catheterization, April 29. She's presented with the symptoms. You can see the symptom there, sleeping trouble. Then there's our symptoms again. Organ side, there's frequency, how this happening there. Then again, dose of frequency, how they have to have there, and then the time. So it's a great service. As you can see, kind of gives you a lot of information and kind of gives you some of the RX norm concepts. You can use this as a feature. There's some medical concept here. So this is also a great service when it comes to kind of get a job. And that's also a beautiful service that we can leverage there. So Comprehend is also a great service that kind of leverage in that side of it. So that's one for you. Then I want to show you a service called as Translate. Again, a beautiful service. Now, when we look at the Translate, it's a what I would call it as it's a neural machine translation service powered by deep learning models that allow for a fast and an accurate translation supporting multiple languages. It's a continually trained solution that allows you to perform batch translation when you have large volumes of pre-existing text as well as real time. And there's on-demand translation when you want to deliver content as a feature of your application. And Translate offers you a secure communication between the services and your application through an SSL encryption. So any content that is processed by the Translate is encrypted, stored at the rest in the region where you're using the service. And additionally, you can ensure that transformation is kept secure and confidential by controlling access to a Translate through the IAM there. So as an AWS service, Amazon Translate integrates nicely with several other AWS services like Amazon Poly for translated speech products, and Comprehend for analysis of translated text, and Amazon Transcribe for localized captioning of your media products. And with Translate, you only pay for what you use there. You are charged based on the total number of characters sent to the API for translation. So that's one of the bits. So as a developer, you don't have to manually extend your application with new languages that meet your customer base. Instead, Amazon Translate allows you to create application that can be used in any language, and you can do with a few lines of code in just a minute. You can call an API from the CLI and SDK and kind of do the job there. And if you're a customer and you're looking for a translation solution, I think it's convenient to stay within the AWS ecosystem for an easy integration with our application and for more efficient security of your data, I would say. But it's not just about ease and efficiency. I would say Translate is powered by the neural machine translation engine, which offers, I would say, an increased accuracy of translation when compared to these traditional statistical or a rule-based translation model. And that's something there. So if you look at, let's say, a customer review of something on Amazon.com, let's say, you can see, most of the time you will see that it's kind of translated from one language to other language, right, using a non-neural machine translation. So you can always get these kind of improvement there, and you can use the translation to kind of get a job. So it's a great way to kind of do this. And Translate is based on a neural network which have been trained on different language pairs, enabling the engine to translate between two different languages. So the model is kind of made of two components. There's an encoder and there's a decoder. So encoder reads the source sentence one word at a time and constructs a semantic representation that captures the meaning of the source data. And then Translate uses attention mechanism to understand the context and decide which of those words is in the source are most relevant for generating the next target word. And I would say one of the most or main advantages of the attention mechanism is to enable the decoder to shift the focus on certain parts of the source sentence to make sure that ambiguous words, the phrases, are translated correctly. So the decoder kind of uses the semantics to represent and kind of do this. So Translator kind of does the part of it and kind of do this job. And you can you do this. So with Translator, things are very, very easy. You have to set up account, create an IAM user, and use it from the console or CLI and kind of do this. So whichever way operates, you can use one of the way to kind of work with Translator and kind of get in that direction to kind of start it. So it's a beautiful service which kind of get the job done. And as I said, you can use Translator in all the capacities to work as a service, and that would be pretty easy for you. So if I have to go to here, and again, a small demo would be fine and great. Let's look for Translate. Powerful neural machine translation, as you can see there. Now, you will see on the left, you have to choose the source, and on the right, you have to choose the target, and you can enter the text. Let's say, I would say today we are studying machine learning on AWS, right? So you can have this, and I can translate this into a different language altogether, right? So I can use, let's say, German, for example. And you will see that the text is translated immediately in the target language text box that is on the right side of it. So this is, and below you can see, if I kind of go there, and below you can see this is a JSON input to translate a text operation. So if we're going to use the command line to connect that, you can use a CLI, and from the CLI you can pass that information to the translated text with the translate there. And for short text, you can kind of give the translator parameter, and for long text, you can just pass in the file, which kind of does that job for you. That's also a kind of great way to do this, which again is I think is a beautiful way to kind of move forward. So this is again a beautiful service. So I think I can use Translate, you can say, for a lot of use cases. I mean, Translate is the right solution for you to translate a high volume of content, and you need to do it quickly. I think you can leverage that. And most use cases kind of fall under one of the categories where I'm translating a web authored content for localization purpose, or either on demand or in real time. And I can even do a batch translating pre-existing content for analysis and specific. So you have a lot of options that kind of happens to work for you, and you can have to do these things. So you can submit different information and kind of translate that as an option, and then that's something which will be able to get a job done. So you can actually put this whole translation thing on your website and just put the APIs, and you can have those things done and kind of get a translation. So if I have a website and I want to put in a translate factor for people to use it, I can use the translate as a service. And that's again a great way to do this. So that's one thing. And then where a service I want to talk about is transcribe, let's say. So that's again a speech to text. Again, a great service for us to do this. Now, when we look at Transcribe, Transcribe is an automatic speech recognition service known as ASR that is designed to make it easy for a developer to incorporate the speech to text capabilities into their application. And if you see, historically, people save most data in structured formats that were relatively easy to search. For example, information is entered into DB via forms or save, right? All these things there. And clearly, we have just spoken about that we are capturing data in a less structured format that is more difficult to analyze on large scale. And in particular, the speech in audio and video needs to be recorded as text before it can be searched or categorized. So traditionally, converting the audio content to a text has required a lot of human intervention there. And someone has to play back the recording and capture all of the speaker words in the text form, and then probably go ahead and review and edit the transcribed content. And even with the benefit of speech to text tool, a lot of editing and formatting is required. And this is particularly true for outputs that require a high level of accuracy and a readability like video subtitles. And the high level of efforts to manually convert these media to text means that only the most critical items are transcribed and valuable information may be overlooked. So Transcribe can help you to address these potential barriers, and Transcribe is a fully managed and a continually trained service that can accept common audio formats like WAV, MP3, MP4, and it can accurately transcribe both your low fidelity and a high fidelity audio. So, which makes, I believe, it's a natural fit for use cases like transcribing customer service calls into some analyzable data or generating subtitles for videos with a high level of accuracy. So Amazon going to use these deep learning to provide accurate and a quick transcription. And it was designed to make it easy for you to get even greater accuracy and useful for the transcribe output. And for example, the output is not just one long in uninterrupted string of text. Instead, what happened that Transcribe uses machine learning to add in punctuation, you get grammatical formatting, so that text you get back is immediately usable. And Transcribe uses timestamps, uses also timestamp every word, which makes it easy to align the subtitles for closed captioning, which makes it easy to index there. So transcripts include confidence level for each word of the transcribe output, which makes it determine where more editing or quality assurance may be required. So Transcribe helps you to mitigate the issues with source audio to improve the accuracy. For example, you can upload a custom vocabulary that can help improve the accuracy of a content you're transcribing and has industry-specific terms like a medical or legal term, which won't be there. So you can choose the language of the source file, and then there are supported language which are there. And Transcribe is going to attribute the speech to different speakers to make it easier for you to interpret the output. Now, because Transcribe was designed to be easy for developers, there are only a few steps to get started, and you don't need to understand how the underlying models work, and you don't need to build your own machine learning models. You basically invoke the service via APIs, and with a few lines of code, you are ready to transcribe the files necessary. You can initiate the whole transcription operation via the console, and you can test the service via console 2 itself. So Transcribe gives you a secure communication between the services and your application through SSL. And you can use transcription via assigned URLs, and you can make sure that the information is kept secure and confidential by controlling access to the transcribe through an IAM policy. So the service integrates easily with the other AWS services like Comprehend, Elasticsearch, or Translate. You can have there, and a simple use case I will tell you. So a call center, uses Amazon's Transcribe to produce transcript of a low fidelity phone calls with a high accuracy. And the center uses Amazon Comprehend and the Transcribe data to identify the key phrase and the customer sentiments so they can classify the calls there. And then they use Amazon Athena to query the data and Amazon QuickSight to visualize the result, analyze the trend. So everything's kind of happened there. So the human resource department uses those. So you can use a Transcribe to generate transcriptions of meetings and training sessions, and then indexing the results using ES and their internal stakeholders. They can quickly search for probably content on demand to locate the topics of interest. There's video production business uses Transcribe to produce transcription of audio tracks for subtitles, and limited editing is done on the output files, and the quality assurance teams can focus on the section that have the lower confidence rating. So using timestamp transfer file, you can kind of align the captions. So you can see that this is a great kind of happens to there and kind of do this job. And again, this service is very nice and beautiful to use in there. So if you go back to the console as we did before and look for transcribe, which is this at the bottom. So let's use something here. So you can see an option, you have to create a job. Let's create a job here. Let's say I will call it as random transcribe test. Just give it a job name, and I think I can use an MP3 file. Let me do one thing. Dummy MP3 files. So let's download some sample MP3 file. Okay, I have no idea what this file is all about. Okay, probably something. So let's download this, whatever is this. I have no idea. But let's see what happens here. So you can actually use a general model, or you can define a language there, and the data needs to be on S3. So what I'm going to do is I'm going to use S3 as an option there, and we'll put my data in S3. I have this bucket here. I'm going to upload this file here that I've just downloaded, and that's the file here. As you can see, I've just added the file. I want to make sure it's public accessible and upload it. This file is there, so I am going to copy this URL and give this URL to transcribe that, hey, this is my file. Uh-oh. I'm not supposed to do that. I'm actually supposed to copy the URI, which is this. Sorry about that. You can see that's the file in here, and it's saying that where I want to manage the output data. So I want S3 to kind of do the job for me. And then, the source language, I think this is English, probably. I don't know that file. What is this? And you can kind of come in there, and I can say where I want to do the output data. I can actually use it. And from there, when you define the output data, you can define the sample rates and all these things. So there are a lot of other configurations you can do this. You can define a queue and all these things. And what you can do once you're able to do this, you can click on next. And there are a lot of audio settings. So identification, also you can choose a multi-split transmission. This is more like audio side of it, content redaction there. So that's something which is there, and you can create a job there. Now, once you create a job, why did I didn't use a subtitle format. Let's use the SRT, right? Probably that would do. Create a job, and you will see this job is running. I can see that the job is in the progress here, which is this. And if I click on this, you will be able to see this process here. And let's see. I should have something. You can see this is kind of the example if your response that's happening, and so the transcription will happen, and sometimes it's complete. You can see there. Now I have the output URL. Sorry, so let's go to my output URL. So same S3 bucket. I'm going to go back and let's see, where is my output URL? Okay, so the text. So let's see. So the text that was kind of copied from this is this, and I was able to get some text. So I think the audio has this some music which has some kind of humming there. So that's kind of get there. So the point here then for makes that if you can use this text, you can use this transcript as a service, and you can then get started with the whole process of kind of getting a lot of text and kind of get the job done, which is, I believe, is a beautiful thing to kind of learn from and kind of move from. And finally, the last piece I want to show you as a small service before we kind of wrap up the day. One of the very important thing that service I would say is going to be the SageMaker. Now, SageMaker is, I think, where has that gone? SageMaker. So this is SageMaker service, beautiful service there. And SageMaker is a fully managed service to help our data scientists and developers to build and train and deploy their machine learning models very quickly and easily. And basically what SageMaker has, it has a hosted notebook instance, distributed on-demand training environment, and you have a model hosting environment that is elastic and scalable and reliable. And using all components kind of end-to-end brings you a seamless experience on SageMaker, so you have a flexibility to use any combination of those components in order to fit your own workflow. And SageMaker provides hosted Jupyter notebook that requires no setup. So with a few clicks, SageMaker console or APIs, you can create about 40 managed notebook instances there. So you can see this is like an instance part of it. So this is a great service again. So with few clicks on the console or APIs, you can create those notebook instances there, and they all come preloaded with data science libraries like Python libraries, deep learning frameworks, about Spark, and so on, and can start processing your data sets and developing your algorithm immediately. And if you want to use extra packages that are not preloaded, you can simply pip install or con install that will be persisted in the notebook instance, and you can certainly run the training jobs hosted in the notebook instance. A lot of times you want to get access to probably more compute capacity that is possible there, and that's something which is there. And for those who want to train their own neural network, SageMaker makes it super easy to directly submit your TensorFlow or Apache MX naive scripts for this teapot training, and you can use an alternative deep learning framework as well by packaging your own Docker images and bring them to SageMaker. So it's kind of a great way to kind of do this and you can always use SageMaker from the console or APIs. And if I go to the so let me kind of show you a quick way of how SageMaker operates there. So if I go to the SageMaker, let's say SageMaker here, you can see the first thing I'm going to create is a notebook. Okay, that's the first thing. So in the SageMaker, everything is about behind the notebook. So you can see there, I have so many services, but we're going to start with notebooks up there. So you can create a notebook instance, and let's give it my dummy notebook. And you have to choose an instance type. So you can see we have ML as the words, MLT2 medium is the one I want to use there. So you can use this. Since I only plan to use it for the demo or dev environment, I can use this as an option there. Or you can run on demand. I mean, whatever works suits you. If you have a heavy lifting trading jobs, use probably a biggest of the option that kind of exists there. But MLT2 medium is the smallest you can see. Then you are going to go into the bigger size of that. And then you have an option of the platform, your IAM role that I'm giving a role access, so root access option. So I'm the root user, so I'm going to use that. Else I would have chosen the part of any role there. So you can have role and kind of create a custom role. I mean, whatever role that kind of operates, you can have that as an option there. You can also, choose different VPCs. You want to do a VPC there. You can choose a VPC in the network section. So I can say, okay, you know what, this is, I want to use my default VPC, and I can use a default subnet, so this is, so basically what notebooks when it's going to deploy an EC2 instance. That's why we're having these things there. And once you kind of define all these things, you create a notebook instance there at that very role here. Let's create a new role for it. Let's just, for now, this demo, I'm going to create a role, and let's create a notebook instance. And you can see there's an instance that's going to be there. And once it's going to be created, you will be able to see that I can run this notebook instance, and it will have all those settings to require to get a job done. So it's a very beautiful tool to kind of get started with building your machine learning models. I mean, we have a great, I think, a 4-day class on ML pipeline. Beautiful stuff. I mean, if you want to get into machine learning, go for that class. That's going to give you everything about running the SageMaker. It's so intensive stuff. So once it's going to be there, I'm going to quickly show you that I will be able to access this notebook. It's going to take a moment to do that for us. Let's keep refreshing it. Once I do this, basically, you can see I don't have an option. So I will have an opportunity to open a Jupyter Lab. So I think it's going to be there soon because so what it's doing, as I said, at the back end, it's launching an EC2 instance for me. Come on. This is going to take a moment. Unfortunately, I don't have a control on this, so you'll have to bear with me for a moment. Oh, man. It normally takes about 3 to 5 minutes. Let's see when this kind of gets done. Unless I don't have an instance, I can't show you some of the sample notebooks, so you know what I'm trying to talk about here. This is the last service for the day. As you can see, we had about 12 plus offering where we have looked at services like, so we have looked at SageMaker, we have looked at Transcribe, we looked at Translate, we looked at Comprehend, we looked at the Deep Lens, and these are services. But you can see we have so many offerings that you can always explore there. So this is a page you want to go, aws.com, amazon.com/machine learning, and you will be able to get all the information there. So that's the page you want to kind of go and kind of get started there. It needs to come in the running state so I can actually do anything. I don't have this option to open Jupyter Lab. It's taking about 3 to 4 minutes. I think we have done that already. So each Jupyter Lab gives you about, I would say a lot of, predefined sample notebooks with all the things you can use, all the ML models that can happen for you. So that's something which is there. This is just weird. Oh, come on. Why this is taking so much time? That's my notebook, that's a role, that's a subnet. Everything looks fine here. It's just taking some time. If I go to EC2, okay. So let this happen. I think meanwhile, what I'll do, I'll give Lila to opportunity to close the session if it happens. Meanwhile, I'll quickly show you the meanwhile workaround, the way around for this. So all we have to do is click on this, go to Open Jupyter Lab, and be able to kind of do and play around with the machine learning right from the AWS. So you see, I wouldn't have to do anything in that capacity to kind of get started. All I had to do is run a notebook instance, and I would be good. And that's pretty much we had to cover for today in this beautiful machine learning class. And by this time, you would have realized that it is such a vast service offering from AWS that I think 2 hours is just nothing for that. We just skimmed through just few services, and even though we could do so many things about that. So that's something from my side. And I'm going to thank you all again for listening me for this. So Leela, I'm going to hand it over to you. Meanwhile, I'm going to refresh it, keep refreshing it.
Wonderful. Okay, thank you. That was a lot of information, really wonderful information. And we are so excited to have had you present this to us. Before we do get into our question and answer session, which is coming up here in just a moment, we are going to hear from Chitra, and she is going to tell us about some of the webinar related courses that we have coming up and the different promotions available. Chitra, are you with us?
Very much, Leela.
Wonderful. You
so
should be able to share
much.
your screen now.
Let me know once you can have a look at my screen.
I can see it, yes.
Great. Thank you. Thanks a ton, Vishal. That was really informative. I totally love the session. Thank you so much. So for the participants who joined us today, I hope you enjoyed the session. But to give you a little bit more on what we have as a value add for you, I would like to give you a overview of what are the offerings that we have from the webinar perspective, from the training perspective, some options that are budget friendly for you to opt for, and things like that. Going forward, this is our website, netcomlearning.com. I would suggest you go on to this page. You can choose the AWS option here, and you end up with this portion of our landing page. Now, this page is so very informative. You have nearly anything and everything to do with AWS available here. You're curious about AWS, you don't want to actually go in for a session, I would suggest you have a look at some of the on-demand learning that's available here on this site. All you need to do is click here on this, go ahead, register yourself, and you'll immediately get access to have a view of all these free learnings that's available here. The second option is you're curious about the ebook or any kind of reading material. You have them available here, which is more from a cloud perspective, but it still gives you an idea of what to expect. You're curious about what we did today as a training, I would suggest you opt for the products here, explore all products, and you will end up with a page which gives you the bifurcation of all the AWS offerings that we have. I would suggest all you need to do is explore, go into the AWS Machine Learning, and like how Vishal had mentioned, you have these wonderful trainings. The SageMaker training is this, which is what he had mentioned during the course of our webinar today. The other aspect now, which I would like to showcase out to you, is some of the solutions that's available from our end for you. If you're looking to pay for a course, but you're looking to plan ahead, the best option would be the Learning Passport, which actually gives you the option to pay in advance for either training by days for a whole duration of a year. It's across all our brands. There's no limitation of which training you can opt for. There are wonderful options. Go ahead and choose one of them. The other aspect is you want to go in for something that's more of a subscription, then I would suggest you opt for NetCom Unlimited. Now, the best thing about NetCom Unlimited is it's actually more towards the corporate sector, but all you have to do is have an official email ID and you will be able to access these programs. One of the key structures as far as I'm concerned is if I go into the offering portfolio, if I click on AWS, I have a huge plethora of offerings. All I need to pay is for just one course, and you can go on and access any of these trainings throughout the year for a 12-month period. I think that's something that should be viable for all of you. Now, other than this, you're not planning to go in for a training, but you're looking to do some webinars, go into our schedules, or go into our options, and you will have more webinar processes. Go into the resource section, choose the webinars, check out the topics that we have which are coming up in the next few months, register for them. I hope the information that I have shared was helpful out to you. And Leila, back to you. Let me just
Wonderful. Thank you so much. Okay, so before we take any more time, we're just going to go ahead and jump right into the question answer session. So
yeah, one more thing. I have can I make the presenter again? My machine came up. I can show that, please.
Hold on, let me give you that presentation right. Did the thing load that you were trying to get up?
Yeah, it took some time. Okay, everyone, see here. This is the machine's running, and we get to open the Jupyter now, as you can see. And I hope you all have known about Jupyter, which is a way to run your notebooks. That's where the world works on the SageMaker. And you can see this is the notebook here. Now, I can run my notebook, so I can upload a notebook. I can open Jupyter Lab also. That's again a way to kind of get started and run your things, which is a Jupyter Lab I can see. So as you can see, we are able to run an instance on the notebook with Phil. And now I can run my entire machine learning. It has got all these pre-featured, pre-packaged libraries and built for you. So I don't have to really do any of those hard work. Amazon will do that for me eventually. And that's something we wanted to have there. So that's is what this bot. You can see we have an option to run all these magical, beautiful libraries there. So that's something I want to address. And over to you back, Leila, again. I am good here. Thank you.
Wonderful. Thank you. Okay, so then we will go ahead and get into those questions. I'm glad that was able to load and that you were able to go ahead and give us that demonstration. So let's see. Our first question that we have, let me get to the top of the list. Some of these, we may have to remember what we were talking about at the time. We do have, it's asked us several times, and Chitra, you'll probably know if there is a certificate for this session at all. Chitra, are you still with? Oh, there you are.
Yes.
Okay.
I'm very much here. I don't think there's a certificate involved. They probably would be having access to the videos though, but that's about it.
Would they be able to get any sort of, if they attended, like certificate of attendance if they needed?
I think so, yes.
Yeah, and just email us at the webinar.
We will probably get it within the next few days.
Okay, wonderful, thank you. So we did have somebody ask if we were going to be doing hands-on in this class. These are not hands-on. Vishal, can you tell us how would be best for somebody to get hands-on training in this?
So obviously, if you're from the ML background, if you're Shan ML, obviously you can go ahead, create a free account and practice them. The best way to really get hands-on, obviously, is to get trained. And as I said, that this machine learning offering from AWS is huge. So the best way I would suggest for all of you is to kind of go ahead, get started, probably enroll for a course to do this. Else, you are free to navigate to the portal of AWS and look at the services, look at the docs, and play around with that. So that's what it is.
Thank you. Okay, let's see. Our next question is, I'm not sure where they're referencing, but I'm hoping you do. What is the frame rate?
Frame rate for what exactly?
I'm not sure. And then a little bit after that, same person asked, AWS Comprehend have emotion, does AWS Comprehend have emotion detection? So I don't know if those two questions are related at all.
The AWS Comprehend, if I say it, as of this moment, I mean, you can do a lot of, so there's an emotion API that you can be used to express on a face there. So you basically get the content there. So yes, there is an API that can be used to tell you they're happy, sad, angry, confused, disgusted, surprised, and there is calm. Yeah.
Wonderful. Okay, let's see. Our next question is, so for a PhD student in computer science who wants to be a data scientist, which AWS certificates would you suggest to earn? And I don't know if
Machine learning.
Machine learning.
Mm-hmm.
Okay. Any others?
Oh, that will do everything.
Wonderful. Perfect. Short, sweet, to the point. I love it. Okay, our next question, you typed a sentence into AWS Translate, and it also showed you JSON for application integration. Why would a person put a sentence in there and get JSON version?
See, you have to understand that when we are using Translate, it's on the console, right? Obviously, you're not going to go on the console of AWS to do that. You have to parse in your content as a JSON via an API to your application. So let's say for an app and there's someone typing on your app, how would you give it to the API? The API understands JSON, and JSON is a schema-less format for storing and transporting data. Okay, that's why we were getting a JSON. So you know that there's a JSON. You're not going to you have your user to go to console and type in the text. You have to somehow talk to the AWS API, send that text that user is typing to translate it back. That's going to be getting into a JSON. That's the format that's you can use to store and transport data. That's why there's JSON.
What a great question. Thank you. Our next question. Sorry, it's my mouse was blocking it out. Somebody just had a comment that the translate configuring went too fast. and that it's an important learning concept. I agree, like we have to get through the content very quickly sometimes, and that's why we do offer additional training courses. And sometimes there's just not time to really.
I want to add in here. I know we didn't even go fast. Trust me. If I had to spend, I can spend a day on one service. So yes, there's so much in machine learning, so much I can't even tell you. So yes, I mean, we had to, I mean, I couldn't even show you, let's say 50% of the services you can imagine. So there's so much. The whole point of webinar is to show you how powerful AWS is and how fast you can go and learn that. I believe that's what we're doing, right?
Yeah. So let's see. Our next question we have is, does SageMaker also leverage Hadoop? Hadoop? I don't think I'm saying that right.
Hadoop with SageMaker, yeah. So the best part that you can use the SageMaker, you can enhance the capability of SageMaker backed by Spark in the MR. So yes, not directly, but you can use Spark, and then the Spark, you can leverage that. You can create a cluster, and from there you can leverage it to SageMaker. So there's integration with the base services there.
Wonderful. Let's see. I do have somebody who said they think that when they were referring to frame rate, they meant when using deep limbs to Lambda. What are the picture clips you can capture, like video frame rate per second?
I'm not even getting the question. When you say deep lens, it's also the basic frame rate. So I'll tell you an example of the basic frame rate is 1030. That's what you get. If you understand who's asking the question, if they get it, it's a 1030 the frame rate.
Wonderful. Let's see. I'm just checking on time to see how we're doing. This webinar is. Let me math here for a second. Okay, I think we're still good. So we did have somebody who wanted to know if there was going to be a playback of the recording, and yes, there will be a playback. Generally, I think it's the next 24 hours. Sometimes though, when it falls on a Saturday, you won't get it until Monday morning. Chitra, if you know for sure, you can chime in and let me know. Let's see what other questions we have. So what are the main factors in massive adoption of deep learning in the recent decade?
See, deep learning is pretty much everywhere. I mean, as I said, when you're getting into, the best example is autonomous driving. I'm sure everyone is aware about Tesla. So deep learning kind of does that for you. So when you want the system to learn from the data that's getting generated, it's deep learning. So you can look around you, you will find deep learning everywhere. Everywhere you can find deep learning. I mean, knowledge discovery, predictive analysis. Everywhere you will find deep learning, in terms of that side as a model. So that's the answer I would say. And if you look for a use case, I would probably could talk about, let's say, computer vision, image classification, NLP. We spoke about automatic prediction. You can have use cases in agriculture, in aerospace, automotive, healthcare. So I'm working on that. Insurance is there. There's manufacturing. There's pharmaceutical. So there's this huge use case I can have for deep lens.
Fabulous. So let's see. We're going to go ahead and take one more question because I looked at the time frame for this and I guess I misunderstood that. So we're going to go ahead and take one more question, and then I think we're going to go ahead and wrap up. So the next question is, do you think a machine learning solution is like a company using rule-based system to classify the credit card transformation as fraud or not? Do you think that's a machine learning solution?
Absolutely. I did talk about it like a few times in the course that in machine learning, you want to know, so it's a binary classification. So whether a transformation is fraud or not, you do a binary classification with machine learning.
Wonderful. Okay, well, with that, I don't see any other questions in our questions panel. So we are going to go ahead and wrap up. But before we do, we want to launch a quick poll to find out how many people might be interested in taking some additional courses. Thank you so much, Vishal, for joining us. You just have so much knowledge on this, and I know we could learn from you for like weeks on end without running out of subject matter, but unfortunately we don't have that much time today. So in addition to the webinar that you presented today, we have a lot of informative webinars that are coming up. So if you guys are interested in any of those or just finding out what they are, you can go to www.netcomlearning.com/webinars/ to register for any of them. And we want to thank you all for joining us and taking time out of your Saturday to join us. If you do come up with any additional questions, feel free to send them to us at webinar@netcomlearning.com at any time. We hope you all found today's webinar to be very informative, and we look forward to seeing you back here with us very soon. Also, feel free to tell your friends and colleagues about our webinars and other courses. Once again, thank you, everyone. Thank you, Vishal, and thank you, Chitra, and have a wonderful day. Have a wonderful weekend.
Thank you, everyone. Bye-bye and take care.
Thank you.